Hi, welcome to Intro to Statistics. This is day one. I'm Todd Richardson and I'll be your pilot for today. Today, what I'm hoping that you get is some reasons why people study and use statistics, a little bit of basic vocabulary, and a strategy for solving proportions. First, I want to start with reasons why people study statistics. To demonstrate, I've got a graph here comparing our X value of years of education to our Y value of annual income for a person. And if I just look at one individual, we have one individual here who has 14 years of education, went through high school plus 2 extra years of junior college, and that person earns $50,000. That's just one individual. What statistics tries to do is look at the bigger overall picture for thousands or even millions of people. And what I hope you notice is, if we look at the many dots of people comparing education to annual income, the more people we look at, the more we see a general trend, and that general trend goes like this. And what I'm attempting to draw is what we call a line of best fit, or a regression line. And the general trend for the dots is, for these many people here, only a few of whom I've got graphed, but for many, many, many people, the more years of education you have, the higher your annual income. That's the general trend. This is the general trend that would be discovered by the use of statistics and finding what we call this line right here, this line of best fit. Another reason why people use statistics, I will demonstrate here. So let me just go to my next item and let me do a little bit of erasing here. So, suppose we have a researcher who selected 40 black labs, and she found that 17 of them had a skin condition of some kind. And she is wondering what percentage of all black labs in the nation suffer some kind of skin condition. Does her research really reflect the bigger population of black labs in general? That is a question that can be also answered by statistics. So, let me now reduce this and let's go to some basic vocabulary. Starting with population versus sample. Two of the terms that we will use again and again are the terms population and sample. A population includes every member of a group that is studied. So if we were studying all American adults, we would be talking about the population of millions of adults in the United States. A sample, in contrast, is a smaller group selected from a larger population. And let me color code sample in red. So when we take a smaller group from a bigger population, that is what we call a sample. Two other terms that I want to define are the terms parameter and the term statistic. A parameter is a measurement taken from an entire population, whereas a statistic is a measurement taken from a smaller sample. What I often tell students is population goes with parameter, both begin with the letter P, whereas S for sample goes with S for statistic. Here's an example to clarify the difference between a parameter and a statistic. So let's look at this example right here. A research group counted 207,818 residents in a county, and 37% of those residents were found to be without internet service. Those two numbers count and measure an entire group, an entire population, and therefore those are parameters. In contrast, when we take a smaller group from the entire county, 180 residents, and we measure 29% of them to say they have no internet provider, well, those are what we call statistics. Those are numbers that come from a smaller sample. Now, if we can move on to random versus biased sampling. Let me do a little erasing here and then go to our next item. So, a random sample is one in which all members of a population have an equal chance of being in the sample. So even if I don't select every member of the county, if I give every member of the county an opportunity to be included in the sample, then the sample is truly random. Whereas a biased sample is one in which only some members of a population have a chance of being in the sample. Let me clarify here. So we have Eugene and Neil, and they want to know how many people are in the town that are going to vote and how those people are going to vote. They both obtained alphabetical lists of all voters in the county, but Eugene went only so far as to poll voters who lived close to his neighborhood or lived in his neighborhood. Neil, in contrast, rolled a die. The die came up 4 randomly, and then he went to every 4th voter on the list. If every voter has an equal chance of being in the survey, then that's a random sample. So what Neil did is what we call a random sample. So if I color code random sample right here, then Neil gives us an example of what we call a random sample. Eugene, in contrast, is conducting what we call a biased sample because he's only choosing people who live close to him, and therefore he's excluding people who live farther away from him. Now, let me erase what I've just done, and we'll go to the end of our vocab. So, let me now reduce that, and let's go to our last page. I want to clarify what makes a variable discrete versus what makes a variable continuous. We will work a lot with unknown numbers or numbers that can have more than one value when a number can only take on or a value can only be one of only a few different selections. Then we call that variable discrete. So, for example, if the letter grade that I get for a semester in a class can only be an A or a B or a C or a D or an F, if I only have 5 different choices, well, then we call that one of a selection from a discrete variable. In contrast, a continuous variable is one that can take on an unlimited set of values, and there are no gaps among those values. For example, if I fill a pool and it can hold anything from 0 gallons to 20,000 gallons, if, for example, the measurement can be 8,212.1 or 8,212.101 or any decimal number from 0 to 20,000, then we've got what we call a continuous variable for the number of gallons that that pool can hold. Lastly, I want to end today's lesson with solving a proportion, and right now I've got an example of a proportion right here. A proportion is an equation in which 2 ratios, 2 fractions, are equal. In statistics, we will have to do a lot of solving for an unknown number in a proportion, and here's an example of that. Suppose we say that 39 out of 150 equals 1,443 over x. What we would do to solve this equation for x is first start with the idea that the cross products are equal to each other. In other words, the 39 times the x will be equal to the 150 times the 1,443. What I have to do to solve for x is multiply 150 times 1,443. And then in order to isolate x and get x completely by itself, I would also need to divide by 39. If I divide 39x by 39, that of course gives me 1x. And 1x will equal what I get if I take 150 times 1,443 and then divide that by 39. That would give us the value of x in this proportion. Hey, thanks for hanging with me. Good luck.